Okay, so in this video, we're going to be looking at the difference between permutations and combinations. And we said that a permutation is an arrangement where the order matters. Combinations are the opposite. They are arrangements which the order doesn't matter. The order does not matter. Essentially, a combination is like when I have groups of people where all of the positions are interchangeable, or groups of letters where the order doesn't matter. So I've got these letters here, A, B, C, and D. And just like I did previously, I'm going to write out all of the arrangements that I can think of just two of these letters. So let's do that. Start off, and then we're going to do something else with them. So we're going to start off with A, B, A, C, A, D, B, A, B, C, B, D, C, A, C, B, C, D, D, A, D, B, D, C. So these are all the combinations, these are all the permutations that we did earlier. Now to find the combinations, we know that the order doesn't matter. So we have to look and get rid of anything that's the same that we've already written. So we had A and B together, so that means that goes away. We have A and C together, so this goes away. We have A and D, so this goes away. We already know that BC works here, and so we can get rid of CB. BD is already shown, so we can get rid of DB. And we only need one combination of C and D, so we can get rid of this one. And so that leaves us with 1, 2, 3, 4, 5, 6 combinations of these letters, because the order doesn't matter. If Fred is working with Joe, Joe is working with Fred. The order doesn't matter, however you put it. So, the way that we do this in a quick, concise way, rather than writing out every single permutation and then crossing off the extras, we have a method to it. So, we have an example here where in a science class of 28 students, how many different 4-person lab groups can be formed? So in a lab group, let's just assume no one has a specific job. Everyone is just co-equal lab partners. It doesn't matter what the order is that they're put into. Joe, Pam, Dan, and Sue is the same group as Dan, Joe, Pam, and Sue. So to find this combination, we're going to actually start by finding the permutation initially, and then we're going to divide by something. So let's find that permutation. 28, choose 4, gives us 28 times 27 times 26 times 25. And then whatever that is, we're going to divide it by the number of unique ways to form a 4-person group, which is 4 times 3 times 2 times 1. We're going to evaluate the top value and the bottom value, and then we're going to figure out what the total is. So that's going to be 28 times 27 times 26 times 25. So that tells us there are 491,400 different permutations of the lab group. But we know that 4 times 3 times 2 times 1 of them, 24 groups of those are repeated. There's 24 times too many. So we're going to divide off 24, and we get 491,400 divided by 24. And that gives us a much more manageable, well, not that much more manageable, but a slightly more manageable 20,475. And This is the combination of our 11. It's still a big number, but it's a lot smaller than what we already had. So, this is the format, this is the notation we're going to be using for combinations. It's very similar to the format for permutations. The only difference is it's a C instead of a P. So this means n number of choices taken R at a time. For example, the combination of 11 choose 5 is 11 choose 5 permutation divided by 5 times 4 times 3 times 2 times 1. So 11 choose 5 would be 11 times 10 times 9 times 8 times 7, which is, let's see, 11 times 10 times 9 times 8 times 7 is 55, 440, over 5 times 4 times 3 times 2 times 1. So that's 120, and that gives us 55, 440 divided by 120, or 462. So it's a much, much smaller number, depending on how the combinations fall. So let's try this next one. 8 choose 3 as a combination. So we're going to start off with our permutation of 8 times 7 times 6, and then we're going to divide by 3 times 2 times 1. Let's see what we get. 8 times 7 times 6 is 336, divided by 3 times 2 times 1, which is 6. 336 divided by 6 is 56. So when we're dealing with combinations, our numbers are a lot smaller. I want you to try the next example and see if you can get this correct. It's going to be 16 choose 4. Do it the same way that we've done it these last couple of examples. All right, so this next example, the answer should be 16 choose 4, which means we're going to do 16 times 15 times 14 times 13 divided by 4 times 3 times 2 times 1. So 16 times 15 times 14 times 13 is 43,680. And we know 4 times 3 times 2 times 1 is 24. So we've got 43,680 divided by 24, which gives us 1,820. All right. Next question. Got 13 people trying out for a 10-person team. How many different teams could be formed? So we've got a 13 choose 10 situation. This is going to be a long one, hard to write down. We're going to do 13 times 12 times 11 times 10 times 9 times 8 7 times 6 times 5 times 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then we divide that by 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, this is a lot, but there's actually a trick here. there's some things that overlap. So I can cut those out, and then I don't have to deal with them. 10 and 10, 9 and 9, 8 and 8, 7 and 7, 6 and 6, 5 and 5, 4 and 4. So really all I have to do is 13 times 12 times 11 divided by 3 times 2 times 1. 13 times 12 times 11, 17, 16, over 3 times 2 times 1, which is 6. Divide that by 6, and we get 286 different combinations. Combinations. Now, if we have some random company that needs to fill 3 identical spots, if we have 8 people apply, how many ways can we hire 3 of them? Well, we can actually check earlier because we know that we did this earlier. We did 8 times 7 times 6, and that was 336. 8 times 7 times 6 was 336. But we have to divide that by 3 times 2 times 1 to get rid of any duplicate permutations, excuse me. And that's going to be 336 divided by 6, which is 56. And that's our answer. Hopefully you got these answers correct. Also, make sure you go and watch the video on permutations and the video on how to do this with a calculator so that you don't have to do this every single time. It's a lot quicker, but I did want y'all to see what's going on and how you do these the normal way.